like on solving for the unknowns, that little category they came up with, they were really clear that there was just one solution. But still, nobody went back to the 3x plus 2x equals 5x. Like, how do you know that one doesn't have one solution? Or the f times 1 equals f. How do you know that? I mean, so how many solutions would it have? Would it have 2? Would it have 5? You know?
Right.
So
yeah.
Just, you know, I would just like to hear why they were clear that it was different about those. So yes, I like that idea that we could revisit it.
Yeah.
You know, like if you had your digital camera, you could take a snapshot of the board and go, well, you know, we came up with this category, but there's still these outliers out here. What makes them different from the two groups we came up with for equations?
And then,
I guess before we finish, so one question that we had brought up at the beginning was, you know, was it too much? Were there too many things? Was it, and I'm just curious what you guys think about sort of the choices that we made in terms of, you know, what was on the cards and how many cards there were.
If there are fewer cards, I don't think as many distinctions and counterexamples would be as ready at hand when people say, oh, but you're putting it there, but that would fit in here, but it doesn't fit in there. So I think, to me, I think the number was right, and it wasn't too intimidating or daunting. I think because of the different formats and the different structures, you had first they were all together, and just, you know, you get together these 2 or 3 people that you think you fit with. So I think they were sort of eased into it, as opposed to, okay, in your group here are these 25 things. You guys sort of, but because of the way they were sort of eased into it, I think it was just enough. And if, yeah, let's say if there were fewer, the distinctions and contradictions wouldn't have been able to be dealt with.
as I said the other day, when you decided to add a few more of, well, it gives you the flexibility of if people are using all of them to discuss all of them, and if there's ones that people like don't even touch, then you don't have to go there. And so like nobody talked about formulas, and so you didn't have to go there. And if you had, it would have been like too many layers, you know. But if one group got really deep into the formulas, you could have discussed it with that group, or potentially had that group bring it up. And so I think that I agree. I mean, I actually think if there were many less, there wouldn't be enough counterexamples. Like people could make generalizations, and there'd be nothing to disprove it if it was not an accurate generalization. And I think that it allowed, I mean, it was sort of differentiated in that way, that it allowed people to like use the ones that made sense to them and disregard the ones that didn't. And you never said, wait, you didn't use this one, where does this one go? And so people got to sort of do it with whatever made, you know, wherever they were. And some group, and actually the group I was looking did use the f times 1 equals f, and there may have been another one. I thought they had 2 that had multiplication. They actually had a group of addition, properties involving addition, and another one that was properties involving multiplication.
There were a few more cards that didn't make it.
Yeah, so they never said that out. They never discussed that but they actually had utilized those. And so I think it allowed some groups to use more than others.
This class was very focused on properties, and I forget who first said the word property. I think somebody said like that one has community. That one has
Derek
the community
started
property.
It, but he was like, "It's this thing." I mean,
yeah, right. All this, you know, they're all. I think he said they're all commutative, or they're all the same
right.
properties.
He did, but he was the one who initially brought up the property idea.
And so with that name, yes, those are the ones that fit there. You know, if in my third period class they were talking about, I think I sort of did a little more prompting and talked about, would this always be true? You know, with like 40 equals 5x, is that true for all numbers? No, it's only true for one. X plus y equals y plus x, is that true for all numbers? Let's try some numbers, and so 3x plus 2x equals 5x fits then in that category because it's true for all numbers category rather than properties. And I think Steve mentioned this group getting into a discussion about 3x plus 2x equals 5x not fitting there because there wasn't a property name for it. It was combining like terms, which is not a property. So really sort of, too focused on what's a property versus this idea of number pattern and whether it's true for all numbers. So, I thought that was good. I thought it was good that f times 1 equals f can stay out, that we don't have to talk about that. Although, in the other class, they said that was a property, that it's the multiplicative identity. And so they saw it as in there.
You know, they had so many different transitions, but I think of a normal class where you give them like 1 or 2 instructions and every table wants to know, so what were the instructions, what were the instructions? And here it was so open-ended, and yet they were intrigued enough by what you were asking them to think about that I didn't hear people asking for, you know, what's the directions. They were willing to just not have clear directions and try to figure things out for themselves, which was really interesting.
I think there's a huge effect of, you know, the research lesson, the other people in here, the cameras, you know, I mean, we've talked about it, you know, they all sit a little taller and they all sort of, they're willing to kind of go that extra step to figure things out, and it's a really wonderful thing that hopefully, you know, lasts for a few days after you all leave.